Continuing on with the third lesson about strings in Java, I wanted to look at how you compare strings. So what I mean by that is how do you compare to see if one string is equal to another, if one string is greater than or less than in terms of alphabetic order. And that's a little different than we have done in the past where we would use these relational operators like less than, greater than, less than or equal to, greater than or equal to, equal, equal, and not equal. Those only work with primitive data types. So you know that strings are actually not primitive data types. They're objects of a class, so we need to compare them differently. So the problem is that writing something like if string name equals string name 2 doesn't give you a syntax error. So if you write that, it won't say that this is wrong. But what it does is it compares the memory addresses, not the contents of those strings. So it's really saying, is the location of where you're storing this the same as the location of where you're storing this, which is not what you want to do. So the next thing we want to look at is, or we want to mention, is that capital or uppercase letters are considered to be different from lowercase letters. So that's to say that comparisons are case sensitive. So if you say if s1 dot equals s2, this is the way you would do it to determine if two strings are equal to one another. And this equals method is called from one of the two strings, it doesn't matter. And in the brackets for the method as a parameter, you put the other string that you want to compare to. And it returns true if they are the same. And that's, like I said, including the case of the letters. And it's false otherwise. So if you do want to make a case insensitive comparison, which is, I would say, most of the time what you want to do, you can use equalsIgnoreCase. Now, I guess if you consider when you type in a username and a password, usually the username is not case sensitive, so you could use equals.equals to compare that. But if you're talking about the password, it's usually that's the opposite. The username, you could say equalsIgnoreCase because case does not matter for the username. For the password, however, most passwords require an uppercase and a lowercase, and they do care about case. So in that comparison, you would use the equals method because you care about case. So let's look at another one. You can compare for one being greater than or less than alphabetic order using compareTo. This kind of takes the place of greater than and less than. compareTo is going to return a 0 if they're exactly the same, which can then basically replace the equals method. It does the same thing if you check if this thing returns a 0. So yeah, just to be clear, equals and equalsIgnoreCase, they return a true or false value. So you can see there is no, it's just the expression here because this gets replaced with a true or false. But in this case, it's returning you a number, an integer. So a 0 means that the two are the same. A negative number means that S1 comes before that one, and vice versa. A positive number if S2 is alphabetically after or bigger than the first one. And of course, you can also do a compareToIgnoreCase if you don't care about case. So those exist for both equals and compareTo. Let's take a look at some examples in code. I think it'll be a lot clearer once we do that. So cat.equals_cat, this should return a Boolean, like a true or false. And in this case, it should return true. So this is a simple case. They're just equal, no question. This one, you have to be a little bit careful because, well, they're the same word, but as we said before, case matters with the equals method, so this should return false. Yes, because C, uppercase C, is not the same as lowercase c in cat. And if we want to run equalsIgnoreCase, now this one should be true because they are equal when you ignore case. Now, let's try the compareTo. compareTo is a little more tricky. So When we compare cat to dog, what it's going to do is it's going to, in a loop, subtract, compare the first two letters of each, and if they're the same, it'll move on to the next letter and the next letter, and compare one at a time. So in this case, it's comparing the C to the D, and they are different, so it's going to effectively subtract the code, the ASCII code for a C and the D. So it's going to return a -1 because C minus D, C is 99 and D is 100. So when you subtract those, you get a -1. Now, most of the time you don't care what number you get, you just care if it's positive or negative or 0, because you don't really care how many letters after cat, dog comes. Most of the time you just care about, is it negative, which means that cat, the first string, is less than the second string, because it's just subtracting character by character the letters in the first one by the second one. As soon as it finds a difference, it returns it, and it doesn't continue looping through the other two characters remaining in the word. So here's an example of that. So if you take cat and cap, C is the same, there's 0 difference. A is the same, 0 difference. Now when it gets to the final letter, it notices that T subtracted P, those are different. Now T is going to have a higher code value because it's further down in the alphabet than a P. There should be a big minus a small, which would be a positive number. We don't really care what number it is. It's actually, I guess, 4 characters difference between a T and a P. So yeah, basically this one looped until it found a difference. And T minus P is, well, if you care, it's 116 minus 112. So you don't have to memorize ASCII codes, you just need to know which, that they come in order and which letter is bigger than the other letter. So if we're saying compare to, remembering it's not ignoring case here, so a lowercase c and an uppercase C are actually different. This is one thing that you do need to know, is that all the uppercase letters from the ASCII table, you can refer back to lesson 1 where we talked about that, all of the uppercase letters come first on the ASCII table, which means they have smaller values. So this would actually be a big ASCII code minus a smaller one, which would be positive. So, and the difference between the two is 32. So for whatever reason, there's some weird characters in there. You might think it's 26 because there's 26 letters in the alphabet, but it's not, of course. So 99 minus 67, if you care, those are the codes. But basically what it tells you is which one comes first out of those two. So here we go. This is a little different here, this example, because it's cat and cats. And like I said before, it loops. So it's going to compare the C to the C, no difference, A to the A, still no difference, T to the T, still no difference. And it reached the end of this, so it can't loop anymore. It's done, and it didn't find a difference. So what happens if there's no difference, but it didn't finish going through all the letters in both words? Then what it does is it subtracts the length. So this is of length 3, this is of length 4. So this should do 3 minus 4 and return -1. Okay, so equals ignore case is probably what you'd want to do most of the time, because you don't care about case when you're trying to alphabetize things and put them in a sorted order. So really you would want this to return 0, meaning they're the same, and that's what compareToIgnoreCase would do. It would just say they're the same and return a 0. So final example here, if you want to see it in, or sort of in some code where you might want to determine which word becomes, what string comes before the other. In this case, we're saying, okay, we have a string 1 and string 2, S1 and S2. If the compareToIgnoreCase is negative, that means S1 must have been less than S2, and that would mean that S1 comes before S2. If it's the opposite, if S1 was bigger, or if S2, sorry, compared to ignore case, S2 is a positive number, that means that S2 comes before S1, because in order for this to be a positive value, would mean that S1 would have a higher code and be bigger than S2. When you subtract them, that would give you a positive number. So, going back to that other slide, sorry, we weren't finished. If in the case of, it's not less than and it's not greater than, in the else case, it must be 0, so they're equal. And one final thing I'll mention that's not really in the book, but I do like to mention it because it's a handy tool. There is a class called character with a capital C, and it resides in java.lang, which means you don't need to import it in order to use it, just like the math class, which has a bunch of handy tools. This has some handy tools to operate on characters. It's called a wrapper class. So it wraps around the primitive data type of char. And it has several useful methods. They're called static methods because they get called from the class, not from the object. So just like math methods, math.pow was called from the math class with a capital M. And you didn't have to make a math object like math m equals new math bracket bracket. Same here, you don't have to make a character object to call these methods. I'll show you some examples on the next slide. And some of the methods, they can determine what type the character is, like is it a letter, is it a digit, and some of them will help you convert from upper to lowercase, etc. So here are some of the methods. If, so now you see how it's called from the class, character with capital C, that's the class, dot is digit, and then you would obviously have to give it a character in round brackets as a parameter for it to figure out if it's a digit or not. So when you give it that char, it would return true or false. So if this thing is true, it's going to do, whatever you want it to do. And there's many others, like is letter or digit, so you can weed out what's a weird symbol by it not being a letter or a digit. And you can determine if it's currently uppercase or lowercase, or if it's a white space, like a space or tab or a new line, etc. And sort of categorize that character. Of course, you don't need to use those methods. They're handy, but if you really want to, you don't need to rely on those. You can do it the old-fashioned way. So here I've kind of done both just to do the job of determining if something's a digit. So I get a character from a string, maybe the first character, for example, and then I can say if character dot is digit ch, which is where my character is, and I would just do something like print it is a digit or is a digit. Alternatively, this would do the same thing. If the character, remember that the characters are really integers, and the integer it stores is its ASCII code. So we don't need to memorize the ASCII code for a 0, for the character 0. We can just say in single quotes 0. So this is not an integer here. This is a character, a literal character, and this is a character variable. So if it's between the character 0, like greater than that, and at the same time less than or equal to 9, the character for the digit 9, that means it must be a character, a number, a numerical digit, because it's between those two things on the ASCII table. So you could consider it to be a digit. Now the same could be done for letters. If you want to determine if it's uppercase, you could just replace this with, in single quotes, an uppercase A, and say if the character is between an uppercase A, like greater than that, and at the same time less than or equal to, and you could put an uppercase Z here, that would mean it's between uppercase A and uppercase Z, so it's an uppercase letter. And you could do the same for lowercase a and lowercase z.